Alright, 12.3 notes is all about the inscribed angles. You guys are familiar with the central angles being the same as the arc, and the arc being the same as the central angles. But what happens when that vertex of your angle is not right at the center and it's on the other side of the circle and stuff like that? When this situation happens, then we have a different formula, which isn't too difficult. Basically all it is, it says that if your inscribed angle, which means the angle is all the way inside the circle, then, meaning that the vertex is on the circle itself rather than in the center of the circle, then what you have is 1/2 of the angle. I'm sorry, 1/2 of the arc is the angle, or the reverse of that, the arc would be twice as big as the angle created. So inscribed angle means that the vertex is on the circle, okay, rather than in the center, and the sides would be chords of the circle, not tangent to the circle, but chords. And the intercepted arc means the arc created by that angle. So right here, so in this picture we have the inscribed arc, which would be AB, created by the inscribed angle with the vertex. Notice that that vertex is right on the circle at C. It's not in the center like in our previous examples. When we have that situation, basically this angle right here, in this example angle B, would be half of whatever arc AC is. Or if you were given angle B, the arc AC would be twice as big. So that's what you basically have here. Now it won't be straightforward all the time. Sometimes you guys are going to have to get creative with the way that your pictures are, and there'll be many different angles and you'll have to follow them to where they touch on the circle. So what I mean by that is, notice X, its endpoints are right here and here, so it means it's like encompassing all of that. So that angle is half as much as that arc. Well, that arc is 80 plus 70. So when you add those together, you get 150, but the angle is half of that. So we would add 80 plus 70, and we would take half of that. So that would give us 75. So that's X. Similarly, when you're looking at Y, you follow the endpoints of angle Y, and you figure out what that encompasses. So that goes from E all the way over to G. Well, we don't have this. This is missing. But we have every other part of the circle other than that. And we know if we added up every arc of a circle, you would get 360. So if you take the 360 and subtract the 90, the 80, and the 70, then you would end up with what that arc FG is. So if you do that, you get 120. And we know that this angle, Y here, is half of that. So this angle is half. So if we divide 120 by 2, then we end up getting, oh no, sorry. Don't divide yet. This is 120 we said. We have to add all those. Got ahead of myself. So we want to add the 70, because we're going all the way across. We got to add all of these. So 70 plus 120, and then take half of that. So when you add that together, you end up with 95 when you divide by 2. And that's for the measure of angle Y. So notice you'll have to create them separately. It won't always just be one. You'll have messy pictures. So some corollaries to that inscribed angle theorem, which basically means common sense, it just follows right from it. Two inscribed angles that intercept the same arc would be congruent because they're both half of the arc, and if they are intercepting the same arc, then they would be half of the same number. Number 2 says an angle inscribed in a semicircle is a right angle. So if you have a semicircle where the endpoints are on the diameter, then that intercepted arc is 180 degrees. So the angle would be 90 because that's half of 180. And then number 3 says the opposite angles of a quadrilateral inscribed in a circle are supplementary. This will come in handy if you can remember it, because there's been times that I forget about this and I do a lot more work than what's needed. So opposite angles of a 4-sided figure that's inside a circle would be supplementary. So if you can remember that, you'll save yourself some work in the end. So basically, I'm going to just do a basic square. It's just saying these two angles right here would be supplementary. They'd add up to 180. Obviously with the square they're both 90, but and at any time that would be the same thing. And this one right here, what they're saying, to give you a picture, change some colors, is if you had this arc and this this angle like that, notice their endpoints are at the same spot. These angles right here would be the same degree. Okay, so in example 2, find the values of A and B. Well, A here, notice this line is a semicircle, so A's endpoints are a semicircle. So this has to be 90 because this is 180 degrees because it's a semicircle. So with that, to get B, you're going to have to figure out what this arc is so that you can figure out what B is, because we know this whole side is 180. So if we figure out what this is, then we can subtract that from 180 and get B. So in order to get this arc, we have to double that intercepted angle, which makes that 64. And then we can subtract 64 from 180 and we'll end up getting our other answer. So with this, we're going to do 180 minus that 64. So that's what, 116? And then we know that this arc is 116. You could also, if you got creative, figure out what this angle is. 180 minus 90 minus 32, and then double that to get your arc. So either way would be fine. Now theorem 1210 says the measure of an angle formed by a tangent and a chord is also half. So in this one above here, if both sides of the angle were chords of the circle, then the measure of the angle would be half of the arc. And this is the same thing, but they want to cover all their bases. If you have a tangent side of the angle and one is a chord, it's still half the arc. Okay, the vertex is on the circle, so you're still going to take half. Alright, so when you do example 3 here, this is going to get really creative, so have your eyes open. Basically what you're doing says RS and TU are diameters, so keep that in mind because sometimes we forget that. RB, line RB, is tangent to circle A at point R. Find angle BRT, so let's just label that, that is this angle right here, and measure of angle TRS. So TRS is going to be this right here. So we've got to identify what we're looking at first. Basically, this blue is going to be half of this arc right here. Oh, and you can't see what I'm drawing. I'm trying, but let's see if I can make this bigger. There we go. This blue, this angle is half of this arc right here. So we need to basically figure out what all the other arcs are, and then we'll have what that arc is. Now we have these wonderful things that we've already learned called central angles. So its endpoints are at R and U, which would make this arc right here 126. These are vertical angles, so that would make this arc 126. So you have to remember all the stuff that you've learned. Okay. Now, if we know that this angle is 126 and this whole thing is 180, then we can figure out what that is right there. Or, to keep that in mind, we could also say, well, we only have 4 arcs here. We have the 2 126s and then we have these 2. So we could go ahead and take 360 minus both 26s. So that is minus 126 minus 126. That's 252. I hope that's right. I'm doing this on the fly. So that would give us, I better do this shorthand. I don't want to do it in my head and it be wrong. So that's 1 and then, so 110. Okay? So between these two right here, these add up to be 110. So if we cut that in half, oh, and by the way, since I just looked at this, we can figure out what this angle right here is because we've already done this work. So that's just half of the 126. Wasn't even paying attention to that. I was so focused on finding that missing arc. So we can throw that answer in real quick. So the measure of angle TRS is half of 126. So that's 63. And then for this one, if we cut 110 in half, get my color. So if we divide that by 2, we end up with 55. So this arc right here is 55, which makes that angle half of 55. So if I take 55, providing I didn't make any errors when I was doing it on the fly, which a decimal seems a little bizarre here, so I might be off by 1, might be 54, but anyhow, 2 goes into 55 twice, 2 goes into 15, 7 with a half left over. Let me just double check that. 126, that's 2, 4, 52. Yep, that's 252. So, oh, that's what I did. Oh, my bad, you guys. I put 250 here. So, yeah, it is going to be, I think it's going to be 54. So that's going to be an 8, which makes that a 0, which makes that a 54. I knew a decimal seemed odd. So, my bad, you guys. You probably caught that before I did. That's 54. So change this to a 4, which makes this much better. Just makes that 27. Alrighty, so, oh, here I go pressing buttons again. Okay, so 54 divided by 2 is 27. So this angle right here is 27. Okay, so sorry for my on-the-fly adding. My answer key didn't have that on there, so I couldn't just look. I had to hurry up and do it. Alright, so anyhow, I am almost done with your guys' final review. If I finished it tonight, I will be happy to post the problems. If not, hopefully you guys can understand this, and we will do more of it. I'm just checking to make sure there's nothing more of it later on, okay, tomorrow. So work out these, try and do the problems on your own and get an understanding. Don't just verbatim fill them in, because it will benefit you later. Okay, have a great rest of your day. Bye.